Okay, let us see how we go about this question. We are still in projection from level ground. A particle is projected vertically upwards from a point O with the speed this after it has traveled a distance of this above O on its upward motion. A second particle is projected vertically upwards from the same point with the same initial speed. Given that the particle collides at the height of this above O, x and v being constants show that at maximum height this is true. Now we have two cases here. We have now two particles. So in my solution, if I'm to, so I have the first particle, and then I have a second particle. These are the particles there. Now, you can see we are going to project them from the same ground, from the same level ground. They are staying at the same point. But for clarity, I'm going to the same ground, and then I'm going to write them separately. So we are assuming we have a particle. This one was from here. Then it had covered. Then we said it was from there. Then here, when it had covered a distance, remember they are giving it this initial speed as the initial speed of 4 v over 3 meters per second. Now, after that covered, let us say at the time it has used for to cover here, let us call that t to be t1 from here up to here. Cover this distance from here, let us call it t. The distance here is going to be 2x over 5. When that covered that distance, then another particle was put up. It was projected from the same point. Assume this is the same point. Now, at the same speed, meaning that if this one is having the same speed, 4v over 3, it means that after t, it's going to cover the same distance because they are being at the same point or at the same speed. Meaning that even this one is going to use t, the time is going to be t1 to cover the distance of d equaling to 2x over 5. Now, if they are colliding at this distance here, from there, this distance here is going to be 2x over 5. Now it means that they are asking for maximum height. It means that this one, of course, it went up like this. Now, if it's going up, it means that if it's using and then they collided, meaning that this one is coming, so assuming that this particle is also here. So if they collided at this distance, it means that this one went up and then came back so that it collides at this distance. So meaning, if this one reaches this distance in the T1, it means that this one going back and coming, going and coming, competing and coming, is also using T1. But now, the time to cover this from here, to cover from here up to here, it means that it's going to be, here the T is going to be T1 over 2. To just go up there, then also coming back to collide like this. It's going to be T equaling to T1 over 2. Why? Because if it's to go back and coming back, right, it means that it's going to use the same time. Because when it was here, this one was at 0. So meaning, going and coming back to collide, it's going to use T1 when this one is covered in this. So meaning there, first of all, this one coming back from there, it's going to be also T1. But when we add this and this, we shall get the time. This one needs to come to this when they are colliding. So that's why we have that case there. Because they are having the same speed, that's why I'm taking T1 here to be the same. So going back and then computing the height and then coming back, it's going to use T1, the whole. Meaning that going to compute that, it's using T over 1 and then T1 over 2, then T1 over 2 also coming back. So when we add this, we get a time, this one from here, then this one also will be using that time. So meaning, if they want the maximum height, there is a very easy, the maximum height we can use the standard equation of motion, or we can first get the time for the maximum height, and then we can get also put in the formula, and then we simplify there. So now, the time for the maximum height, I think we are going to add this. The time for maximum height is going to be t equaling 2. We shall add this one, t1 plus t1 over 2, which is going to give us 3 t1 over 2. So using the second equation of motion, ut plus a half at squared. I think we can see. Now, if we have this, now we can easily, we want to get our t, or to get it, we have the distance, it's going to cover the maximum distance. We have the time, we have the initial velocity, we also have. So, meaning now the distance is going to cover, it's going to be the maximum height, which we are going to call h. It's going to be our u, which is 4v over 3, into the time it's going to use, which is 3t1 over 2. Then minus, because it's going to be acting against gravity, so a half into now g t. Okay, let us put our t where the density we are going to put this. So we are going to be having 3t1 over 2 the whole square. So from here, I think we can easily get our maximum height. But the question is going to be, what is this t going to be when you have it there? So they are simplifying is that we are going to be having our h equaling to these two cancels. We get 2v, this 2, then this one, t1, then minus. Here we are going to be having a half g into 9t squared 1, the whole over 4. But the question is, what is our t1? Now, our t1, you know that our v is going to be equal to u plus at. Now, you know that at maximum height, the distance is going to be 0. At maximum height, this v is going to be 0. So now putting it there, we have 0. Our u is going to be 4v over 3. Then minus, this is going to be our v. Then the time we are using for this maximum height is 3 to 1 over 2. So taking this side, I have 3g to 1 over 2 equaling to 4v over 3. So when you take this and you divide through, you shall have our t1 equaling to 8v over 9g. So meaning, if we substitute there, now our h will be equaling to 2v into now our t, which is 8v over 9g, then minus a half g9, so now this one is going to be 8. I think this is going to be now 8. Into now our t squared. Our t squared, which is here, so we will put there, we are going to get 64 v squared over 81 g squared. And you see by this, we are going to get our 9 there. This one is going to cancel with that. This one we are going to get our 8. So that's what happens if you simplify. Our h is going to be, when you multiply that, we get 16 v squared over 9g, then minus, here remaining with 8v squared over 9g, which we can every see is going to be 8v squared over 9g. Cross multiply, so our, when we cross multiply this to this, we are having 9g h equaling to 8v squared. Now, the easiest approach of getting this is when, alternatively, you could use v squared equaling to u squared minus 2as. Our interface at maximum height is 0, equaling to this, which is our 4b over 3 squared, then minus 2 into b, then our s is going to be height. When you take this side, we'll be having 2bh equaling to 16 v squared over 9 by this one minus 2. When you multiply, you get 9gh equaling to 8 by this 2, there 8 v squared. And you see here you would have reached earlier if you just do that approach. So anyway, I wanted this time because I was going to use it. So alternatively, you can handle it that way. So it's up to you. Then in part B, they're telling us that when the particle collide, 9 is equal to that. Now, when the particles collide, you see that time for collision is going to be, now for this collide, it's going to cover this time, then it's going to cover this time, then plus this time. So it's going to be now, our t is going to be t1 plus t1 over 2 plus t1 over 2, which will give us 2t1. So meaning, if I come and I get my time here, it's going to be 2 into our t1, which is 8v over 9b. So it's going to give me 16v over 9b. So mean now the time of collision, remember the distance it had covered. Remember when you go up and you come back, the displacement there is 0. So meaning after this time here, this particle just covered 2x over 5 at a distance. So 2x over 5, that's the distance it would have covered. So our s equaling to t, then plus a half at squared. Remember it's going against gravity. So this will give us 2x over 5 equaling to our u. Our u is 4b over 3 into 16v over 9g, then minus a half g into, when you square, our t. Now this is going to be our t. So when you square that, you get so when you square this, you get 2. When you square, okay, when you square 16, you get 2, 5, 6, b squared over 8, 1, b squared. When you square it there. And now you see, if you simplify, this one is going to cancel with 1 b there. And then is there anything else that is cancelling out? Yes. 2 is going to divide this number into 1. It's going to be 1, 2, 8 when you divide there. So mean that now my 2x over 5 is going to be, this one is going to be, you're going to be having 16 times this, we have 64 b squared over 28 g, then minus, here we have 128 b squared over 81b. When you get LCM, that LCM is going to be 81b. So this goes here, I think this is 27 by the way, when you find it, it's going to be 27. So 27 goes here, 3 times 3 times 64. We are getting 192. 192 b squared minus 128 b squared, which is going to give us 64. v squared over 81 gig. So cross multiplying there, we shall have, they want us to prove our h. Sorry, we don't have anything like h. We don't have our h. Where is our h? When are we bringing in the h? So it's that in our formula, we don't have anything like v. So we are going to make v the subject, v squared the subject from there. Anyway, so now we start. If we cross multiply, so we have, when we cross multiply this to this, so 2x over 5 is equal to 264 v squared over 81 b. So when we cross multiply this, you see by this ones, by this we shall get 32. So when I cross multiply this side, I have 81 bx equal to 32 times 5, 160 b squared. So now our task is to remove this, is the g, okay, is to remove b squared. From here, r b squared, you see, is going to be 9d h the whole over 8. So if I come and I remove it here, implying that now 81 dx is going to be now 160, now times 9 dh the whole over 8. Okay, so I think we can see this d is going to down, then this 9 will go in here 9 times. Then what else? We have our 9x, then by this one, by this 2. So we have now 9x equaling to 20. Okay, this one goes here 20 times 20 times h. And so our proof will be out just like that. So that's how we handle that. I wish you well.